Here's the solution for day 1, problem 1. Question A, rewrite the number into standard form. So let's begin by copying down this number in scientific notation. And when I copy it down, I'm thinking ahead to what is going to happen because the exponent on the 10 is a negative number. As I think about what's going to happen, the decimal point is going to end up being moved to the left. And so I'm leaving some space here when I write this down to accommodate that. So multiplying a decimal number by 10 to the negative 5th power will have the effect of moving the decimal point 5 spots to the left, creating a smaller number. 1, 2, 3, 4, 5. The decimal point is going to end up here, and there's going to be some zeros filled in as placeholders. That creates the number 0.0000522. Question B. Rewrite the number into scientific notation. So we want to take this standard decimal number and write it so it has the times 10 and some exponent on the 10. So let's begin by copying that down. And that way we're able to work with it and manipulate the decimal point. Now to change this to scientific notation, we want to have one non-zero number to the left of the decimal point. And so that means we want to put the decimal point here so that the number 4 is that number that's to the left of this dot. And that means the decimal point needs to be moved 1, 2, 3 places. That will create 4.52 and then times 10. Now I moved the decimal point 3 places, but I don't want to put a positive 3 as the exponent, because when I think about the meaning of a positive 3 exponent, it would change this decimal number to a larger number. We need to use a negative exponent on the 10 to represent this small decimal number in scientific notation. Now day 1, problem 2. Question A. Solve this equation. And then question B, check our answer. So question A, let's copy the equation down so that we're able to work with it. And I'm going to draw a vertical line downwards from the equal symbol. And now I want to isolate the variable x. There is an adding 2 next to x, and there is also a 5 which is being multiplied to a quantity that contains x. Let's remove this 5 times. That way the x plus 2 will be alone, and then in the next step we can remove the 2. So I can remove 5 times by dividing by 5 on both sides of the equation. 5 divided by 5 makes 1 times the quantity x plus 2. And that is equal to negative 25 divided by 5 is negative 5. But instead of writing 1 times the quantity x plus 2, instead of having 1 x plus 2, we can just write x plus 2. That's 1 x plus 2, and that is equal to negative 5. To remove the plus 2 underneath, minus 2 and minus 2. The x can be brought straight below. Plus 2 minus 2 makes 0, and that equals negative 5 subtract 2 is negative 7. And so the answer that we think is correct for x is negative 7. In part B, we can check whether that works. So go back to the original equation, and where the variable is, let's substitute in the answer that we think is correct. So negative 7 filled in for x. And then plus 2, and then we're wondering, is that equal to negative 25? If it is, then our answer is correct. So let's work out this expression and see if this does make negative 25. Okay, following the order of operations, working inside the parentheses first. Negative 7 plus 2 is negative 5. 5 times negative 5 is negative 25. And remember, we were wondering, is that equal to negative 25? Yes, it is. So this checks, and x equals negative 7 is the correct value for x.